everyone, ito si Dr. Esperanza at welcome sa aking YouTube channel. And for today, we're going to be working on some calculus lessons at tuturuan ko kayo kung paano gamitin ang derivative ng isang function at bakit tayo kumukuha ng derivative ng isang function. At ito ang isa sa mga topics na kailangan nyo matutunan bago kayo compute ng mga derivative ng mga functions gamit ang iba't ibang derivative rules. So do stick around at tuturuan ko kayo kung ano ang derivatives, paano gumamit ang derivatives, at bakit kailangan nyong kunin ang derivative ng isang function. And welcome to our calculus workshop, and for today we're going to be working on the next level of our calculus lesson, which is finding the derivative of a function and using the derivative of a function in answering some problems involving mathematics. Alright, so it's all about, calculus is all about connecting what you have learned from algebra and why it matters so that you will understand why you're doing complex math processes in calculus. Here's an example. So let's say we have a function. This is a parabola, if you can see. So if this is a parabola, this parabola is actually 2x squared minus 2x minus 4. And in this parabola, your goal is to answer this question. And the question in this particular math problem is to write the equation of a secant line at 0, -4, and 2, 0. As I mentioned last week, if you don't know the language of math, this can be a problem that is looking like a Chinese word problem. 1. Do you know what a secant line looks like? No? Do you know what a line looks like? Yes, okay. So at least we have a connection there. So you don't know what secant line, but you're supposed to produce it. So how are you going to produce something that you don't know anything about? So secant line is basically a line that is going to pass through a certain, or at least 2 points in a given function. And in this case, since you're given 2 points, let's plot those 2 points, because I'm pretty sure you can plot points in a graph, right? So it's 0, -4. 0, -4 is somewhere here. And 2, 0 is somewhere here. And in geometry, how many points do we need to construct a line? 2. So by context clues, since we are given 2 points and we're looking for a line, although this sounds really foreign to most of you, just connect the dots. And that is the secant line. So secant lines are basically lines that is passing through a function twice. So you have 2 points in that line. So this is a secant line. All right, now you're looking for the equation of a secant line. Do you remember how to write the equation of a line in an algebra problem? Do you remember how to write the equation of a line given 2 points in an algebra problem? y2 minus y1
over x2 minus x1.
Oh, so you remember something. And that is one of the things that you need to know and use to be able to write the equation of a line. But that's not enough. That is just the formula for finding the slope of a line given 2 points, right? But in writing an equation of a line, this is the formula that we're going to be using. The point-slope form. So the point-slope form is a formula that we use to construct the equation of this secant line right here, also known as just a line, given the point and the slope from the word itself. Now, in this formula, since it's a point-slope form, we're going to be replacing the point and the slope so we can write the equation of a line. And in this formula, this is your coordinate for your point, and that is your slope. Do you know what the m is? The slope. So how are we going to find the slope then? Using the formula, right? This is the slope formula. So we can solve it using algebra. So can you please solve for the slope of this line given the 2 points? Of course you can.
Oh
yeah, I was like, wait.
An x1.
Hmm?
Both say y1 and x1.
Alright, let's put 2 and 2. Okay. Typo. Do I need to edit it?
Is it
No.
the other one?
Yeah, I was like,
What is the slope? Is it 1/2? 2? So is it 1/2 or 2?
2.
2. And you use the formula to find the slope, right?
Yes.
Do you want to know another way on how to find the slope given a graph? We know that the slope is rise over run, right? Do you understand why it's called rise over run?
yeah.
How many points you go up and how many points you are going to the right, right? These are your 2 points. Find a triangle. One, two. 2 rise, 1 run. Done. So that's another way of computing for the slope graphically, using a formula and using the definition of the slope. Alright, so now that we know our slope and now that we have our point, and you can choose any of these 2 points right here. Let's choose the first one, 0, -4, with a slope of 2. Can we now write the equation of a line? Of course, because all you need to do is to use that formula, plug it in the value of y1 and then x1, and you have your equation of the secant line. Can you please write the equation of the secant line we're looking for? So finding the equation of the secant line is as simple as plugging in the value of the point and the slope. So this is the equation, y minus y1 equals m times x minus x1. All you need to do is to replace this with this, and that. So the equation is going to be y plus 4 equals 2x minus 0. And you're finished. That is the equation of the line, using the point-slope form of your given problem. Now, can you simplify this further? Of course you can. But for now, let's leave it into point-slope form because that is an acceptable equation of a line in calculus. Easy, right? So let's do a recap. You're given f of x, which is a parabola. You're given 2 points in your parabola, and you need to produce the equation of this secant line, which is connecting the 2 points. And we're able to produce that using the formula, finding the slope, and then plugging it into your equation. Write the equation of a secant line that passes through x equals -1 and x equal to 1. How do you think you will be able to answer this problem? The difference between example number 1 is that in example number 1, I've given you the 2 points explicitly, right? 1. And we know that x equals -1 is somewhere here, right? And x equal to 1 is somewhere here, right? And we know from last week that x equal to a number is a vertical line, right? Boom, boom. Those are the 2 clues that you have. But you need to produce a secant line that passes through those 2 lines. So how are we going to produce that?
Point.
Yes, the point of intersection of those 2 lines right there. So we have here our f of -1 because we need to find this point, right? And we need to find this point as well. And to do that, you just have to substitute or just look at the graph. Those are the 2 ways on how to find the f of -1. So what is f of -1?
0.
0. What is f of 1?
-4.
-4. All right, so we have 2 points now, right? So now that we have 2 points, which is this point and this point, we are now going to produce our secant line. So now we have another secant line. Can you now write the equation of the secant line? What is the next piece of the puzzle that you need to figure out to write the equation of the secant line? The slope. Did you compute for the slope? What's the slope? -2. And you know that your answer is right because the line, the secant line is going down. So if the line is going downwards, you know that the slope is equal to a negative number. So your slope is probably right, but is it really -2? I'm going to use my graph. So this is my triangle. 1, 2, 1 run. So it's still 2 over 1, but since my slope should be negative, I'll write -2. Boom, -2. And now that I have my slope, and I can use any of the 2 points either this one or this one, it doesn't matter. It is still going to be the same secant line. We'll be able to produce the secant line that we're looking for right here. And that is going to be y minus 0 equals negative 2 times x plus 1. Is that the same equation that you have?
Yes.
So if you use this point, then your equation will look like this. If you use this point, then it will be equal to y plus 4 equal to negative 2x minus 1. Are they the same line? Is this and this equal? No? There. So now it's positive 2, and then we have, is it the same now?
Yeah.
Yes.
Which is equal to negative 2, right? So they're the same line. So whatever point you use, it's still going to end up the same line. Okay, it's still easy because it's still algebra. The two examples that we did are both an algebra and geometry problem. Now look at this problem. Tell me what's the difference between this problem and the other two. One, it's a tangent line, and what else?
It only gives one x.
You're only given one x value. So, one, we're looking for the equation of a line. So you know that you need to produce a line somewhere here. But the problem is, now we have a tangent line. Do you still remember what a tangent line looks like, or the definition of a tangent line?
Goes through me.
Yes. Or it's just basically a line on the function that will touch that particular function only one time. So in this case, let's analyze this given problem. This is f of x. We need to produce a tangent line at x equal to 2. And where is x equal to 2? Somewhere here, right? And we need to produce a tangent line somewhere here on this point right here. And a tangent line only touches the function one time. It cannot touch the function twice. So if this is your point, can I have a line that looks like this?
No.
Why not?
Because it doesn't.
Because it will touch the function twice. Can I have it like this? No. So I need to be very careful in putting my line on the function so that it will only touch it one time. So maybe somewhere here, right? So are you convinced?
Yes.
Okay, so that's our line. Magic. All right, now, but what is the challenge in this third example? It's just giving us 1 point. And what is the problem if we only have 1 point and we're supposed to find the equation of a line?
We can't find the slope.
We're not going to be able to find the slope because the slope formula is change of y all over change in x. So what are we going to do to be able to write the equation of a line? And this is where an algebra problem is now transformed into a calculus problem, because now you only have little clues in your problem, but you need to produce a mathematical process on how to write the equation of a line. That is why in mathematics, and just like in any problem in particular, not just a math problem, the more clues you have, the easier you'll be able to solve a certain problem or puzzle, right? And the less clues you have, the more likely that you're going to spend more time digging in and making sure that you'll be able to answer that particular problem. Same thing with this one. Since we only have a few clues, we're going to do a little bit of work to do or answer this problem. And to be able to do that, we're going to be using this particular formula. This is the formula that will help us find the equation of the slope in any given point in your function. That's basically what this formula is telling us to do or find. Now, can you understand these symbols right here in your formula? Limit of f of x plus h minus f of x all over h as h approaches 0. Do you understand this formula a little bit? First, in the formula, we need to have f of x plus h. We also need to have f of x. Do we know what f of x is? Yes. Do we know what f of x plus h is? Not yet, but we can find it, right? How are we going to find f of x plus h? If I have f of x equal to 3x plus 5, how am I going to find f of 5? Right? Yes, by plugging in 5 to the value of x. What if I have this f of x and I'm looking for f of m? What is f of m? 3m plus 5. What if I have f of m plus 2? What is f of m plus 2 in your equation then?
3 plus 2 plus 5.
So now, can you find f of x plus h now? We're going to use 2x squared minus 2x minus 4 and replace this by this so we can produce that, right? Now, it's going to take a little while because as I mentioned, we only have little clues, so we're going to do a little bit more work. So, let's clear this and solve this problem. In this problem, how are we going to simplify x plus h raised to the second power? Am I just going to distribute my exponent to x plus h? Yes. So we're going to expand this into x plus h times x plus h. We can get rid of that and use the expanded form of our x plus h quantity squared. So we'll have 2 times x squared plus xh plus xh plus h squared minus 2x minus 2h minus 4. Did I do my math right? Okay. Can I further simplify this? Yes. This form now of my f of x plus h. Let's see. 2xh, 2x squared, 4xh, 2h squared, minus 2x, minus 2h, minus 4. Alright, now we're able to produce this. Minus f of x, which we know is just 2x squared minus 2x minus 4, right? Now, we're not finished yet because we're just able to produce this and this. Now we're going to solve for the limit. How are we going to solve for the limit? We're just going to put them all together. So the limit of f of x plus h is this. I'm going to copy it now. Minus Alright, all over h. Can I still further simplify my numerator? Distribute the negative sign, right? Okay. The clues we have in a math problem, the more work we're going to be doing. Can I combine like terms?
Squared.
And this. What else?
2x.
This one?
Yes.
Is there anything else?
The 4.
So now our function is becoming smaller and smaller. So we now have a limit of 4xh plus 2h squared minus 2h all over h as h approaches 0. Now, if we substitute the value of 0 to h, do you think we'll have an indeterminate if we do that? This is going to be undefined. Is there anything else we can do to simplify the fraction so we can get rid of the h at the bottom? Take out the h, factor out the h, and this will become h out, 4x plus 2h minus 2 all over h as the limit of this approaches h equal to 0. And what will happen to that? Now we can cancel it. And what do we have left in our function? 4x plus 2h minus 2. We haven't solved the limit yet. Now we can substitute, right? Okay, yes.
Why didn't we take out 2h?
Why did we not take out 2h? Because we still have 1h right here.
Oh.
So we took out one of them. So now we have this. So if we plug in the value of 0 to our function, what will it be equal to?
4x minus 2.
There.
Oh my God.
And what is that? This is the equation of the slope. So m equals 4x minus 2. We're able to produce this using this formula, which is basically helping us to find the slope of the tangent line at any given point on your f of x. And now we can find that little slope that we're trying to find a while ago. But since we only have 1 point given in the problem, we need to go through all these steps because this is what we use to find the equation of the slope. So let's go back to our function. And if you need more examples on how to find the derivative of a given function, just click on this I button right here in the corner and I'll give you more examples and more videos on how to find the derivative of f of x given different rules of your derivative function. And complete the problem. Now that we have the equation of the slope, now that we have the point x equal to 2, what is this point right here? If x is equal to 2, what is y?
0.
So we have a point, we have the equation of the slope, but do we have the actual slope of the line? No, not yet. So how are we going to find the actual slope of the line? It needs to be a number or numerical value. We're going to plug in the value of your x to the equation of the slope so we can find the slope of this line right here. And what is it equal to? 6. So now we have the slope at x equal to 2, which is 6. Can we now write the equation of the line? Yes, 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 and yes, minus 2. And that is the equation of the tangent line at x equal to 2. And we're able to solve that because of this formula, which is basically the formula that we're going to be using in finding the equation of the slope in any given point in your f of x. We're going to be using the same f of x. Now, I want you to write the equation of the new tangent line as x equal to 0. Can you solve it now? So now you don't need to use the limit of the function formula because now you have the equation of the slope at any given point. You can have a point here, a point here, a point here, a point here, 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 anywhere in your function and produce a tangent line in that point and you'll be able to find the equation of that tangent line because now you have your equation of the slope. Yes, because at x equal to 0, your y value is equal to -4 and your tangent line is somewhere here. That's the tangent line. So that means your slope should be negative. Do you have a negative slope in your equation? Because you have a line that is negative. So using your equation, is this the slope or the equation of the tangent line that you were able to produce?
Yes.
Okay. Now, given now that you have this function and this formula, and again, ito po ulit si Dr. Esperanza at thank you for watching my lesson on derivatives. At kung nagustuhan nyo yung video na napanood nyo, please like, share, and subscribe to my channel. And please subscribe to my second channel as well para mas dumami kayong mga students na matutulungan ko. See you again next time sa aking workshop dito sa Barstow Community College. Bye! This is the video. So this is our last minute here in Chapman and we're going home back to Barstow.